Hey everyone, welcome back to Around the Farm, the podcast about all things ag. I'm your host, Clint Schaffer, and today we're going to be doing a deep dive into the Niño Southern Oscillation, otherwise known as ENSO, and the La Niña pattern that we're expecting to see this year. Once again, we're joined by Brad Coleman, an atmospheric scientist and the Director of Weather Strategy for the Climate Corporation. Brad, welcome back. It's been a few episodes since the last time you joined us here on Around the Farm, but how about you give our listeners an introduction to yourself?
Sure. Thanks for having me back on Around the Farm. Looking forward to the conversation. I'm an atmospheric scientist for climate part of Bayer Crop Sciences, and we work on making sure that we have the weather resources that we need to do the business that we do at Bayer and climate.
Well, speaking of some pretty cool things, I heard that you may have just had a pretty big honor here that happened to you. How about you explain this pretty big deal here?
Sure. This year, I was actually asked by the American Meteorological Society to put my name in the hat for president, and just found out a few weeks ago that I was able to win. And so now I'm president-elect for the American Meteorological Society. And we're a society of about 14,000, generally are scientists, atmospheric scientists. And it's a great time to have that role. A lot of important things going on with climate and weather and making decisions on the direction for weather in the United States. So I'm excited and humbled, but excited to take on this new role.
Well, congratulations, Brad. I mean, I can't think of anybody more perfect for that role than yourself. So congratulations again. So,
thank you, Clint. Yeah.
Well, Brad, last time we had a discussion, we talked about, just some of the impacts of La Niña, and you were fairly confident that, going into 2022, that we were really going to see that very similar cycle. So I thought it'd be good to bring you back on and really do a deep dive around just what that means for everybody in the ag community, what that means for anybody, right? How does this impact, I guess, the world as we start thinking about La Niña?
Yeah, we were. And, weather forecasting has its challenges, as we all know. And especially when you start looking beyond the first, 10 days or so of the forecast, things even become more uncertain. And those who really focus and invest in seasonal forecasting, subseasonal forecasting, really looking out several months or even, out to a year, they're looking for any little clue in the atmosphere or the Earth system that will give them that little bit of an edge. And the El Niño and La Niña, or ENSO, as scientists call it, that's the one place that we can build up a little bit of confidence. And there are a couple reasons there. One, they're relatively slowly varying. So once you have this ocean response that we typically, La Niña and La Niño reply to the tropical Pacific Ocean, you can be relatively confident that it's going to be there for a while. And then we can really look at what is the relationship between the ocean and the tropical Pacific and weather around the world. And it's a fascinating story, but it's one that seasonal forecasters really love because it does give them that edge. And going to this, through the summer, we saw La Niña forming. It developed certainly by, late summer, early fall. And so all of a sudden you can be fairly confident. In fact, the Climate Prediction Center puts a 95% confidence that this La Niña will persist all the way through Northern Hemisphere spring. That's a great piece of information for a seasonal forecaster.
Okay, so I hear the terms La Niña, the terms El Niño. Could you give me just like an easy to understand way to understand the difference between those two? I hear them all the time, and I'm still probably a little confused on the difference.
Okay, we'll give it a go. But it's taken the scientists about 100 years to figure it all out. It started when Sir Gilbert Walker from the UK, he was assigned to go to India and figure out why the Indian monsoon occasionally failed. So he went down there and did his homework, and we can return to that fascinating scientific investigation and story. But it really is all focused on the tropical Pacific Ocean. And it helps to start with what is the sort of the pattern in ocean temperatures from the west coast of South America all the way westward across the date line into Indonesia. And what typically we find on sort of the average pattern is that we have tropical trade winds, right? We've all heard of tropical trade winds, and they blow generally from east to west. So if you picture the large Pacific Ocean with this general pattern of winds blowing from east to west, so pushing the water towards Indonesia, what you end up doing is you pile up the warm water in the western tropical Pacific, and you bring up some cooler water in the eastern tropical Pacific. And that's the pattern. And how much difference are we talking about? Typically along the west coast of South America, along the equator, your temperatures are around 70 Fahrenheit or so. And by the time you get to the far western Indonesia area, the temperatures are in the mid 80s. So if you and I were to go swimming, we would recognize the difference between 70 and the mid 80s. And the atmosphere recognizes the difference between 70s and the 80s. So La Niña, what it really means is those trade winds are stronger. Ultimately, the atmosphere is working harder. It's pushing the water farther and farther west and bringing up more and more cold water. So in the simplest term, that's La Niña, is the warm waters in the Western Pacific and the waters colder throughout from the dateline all the way to South America is below normal.
And so when you talk about the temperature difference, so if La Niña is bringing in colder, how much does that end up dropping it from that 70-some degrees? I mean,
yeah. Great question. And we're really, it's not going to sound very impressive. We're talking about shifts of temperature between maybe 3 and 5 degrees Fahrenheit.
Okay.
Between these different phases. Extremes, it can go a little bit, but not a lot. But the critical piece here, and what's so fascinating, Clint, is that the atmosphere, thunderstorms in the tropics are really influential about the jet stream, what we deal with it here in North America. And there's sort of a switch at about 83 degrees Fahrenheit or so, at which if the water's colder than that, it doesn't support thunderstorms. And the water's warmer than that, it does. So all of a sudden, we have this line moving back and forth along the equator with thunderstorms toward the west where it's warm enough to support thunderstorms and no thunderstorms farther east because the water's too cold. And that is the feedback that we're so critically focused on in North America and a lot of the world because the position of those thunderstorms influences our jet stream.
Wow. Which I would assume then influences the rainfall across the Midwest then as well.
Absolutely. That's the whole puzzle. And in fact, there are global connections between this pattern in the tropical Pacific. The Pacific Ocean is huge. And this shifting in water really does influence many areas, all the way back to the Indian monsoon failure that I mentioned has to do. And that's what Sir Gilbert Walker figured out. Is he said, certain phases and going on in this oscillation, all of a sudden the monsoon fails, the thunderstorms shift farther east in that case, and there are all sorts of fascinating patterns associated with this sloshing back and forth of warm water in the tropical Pacific.
Now, I use the term La Niña and El Niño, yet you said the weather community uses ENSO, and what does that mean then?
ENSO stands for, as an acronym for El Niño Southern Oscillation, and it's kind of grabbing a couple pieces here. The Southern Oscillation is the label that Walker used, is this oscillation wavering of pressure, and he saw it in the pressure. He didn't know what was going on in the ocean, but we know it's the same thing reflected in two different sort of metrics. So he called it the Southern Oscillation. And, gradually scientists spent more and more time trying to figure it out. The natives along the west coast of South America, they're the ones who grabbed the name El Niño or Christ child because the warm waters would appear around Christmas time. Oh. So they would see these warming episodes and they called it El Niño. So then the scientists came along and we said, well, if you have El Niño, you probably need to have the opposite phase. We'll call that the young girl or the female child, and we will call that La Niña. So it's a little bit of, fascinating history and a little bit of scientist tinkering.
So if La Nina is 3 to 5 degrees less, right, or cooler, right, in those times, is El Nino then would I think of 3 to 5 degrees warmer than average?
Yeah, you're catching on to it. Yeah, absolutely. But it's again, where is this warm water? In El Nino, what happens is those trade winds weaken, and now that big pool of really warm water in the Western tropical Pacific, that gradually flows eastward along the equator, and those temperatures go up, and now you exceed all the way east of the date line. All of a sudden, the temperatures are into the lower 80s Fahrenheit, and so then they bring thunderstorms with them, and they're big, persistent thunderstorms. And again, that's the connection to our weather.
So, if we can either have La Nina or El Nino, what is it called if neither of those are happening?
Yes, indeed. We're not always in one or the other. And that's called ENSO neutral. A neutral phase is kind of average, which is what I described a bit ago. It's just kind of that average, cooler waters in the Eastern Pacific, warmer waters in the Western, a lot more thunderstorm activity in Indonesia and in that area than, that's just kind of the pattern. So it's really waverings of magnitude of that pattern between La Nina and El Nino.
Well, and it also seems like we just got out of a La Nina, I believe, in this previous year. So now we're going to roll back into another La Nina. Are you seeing the frequency of this increasing? I mean, it seems like we're having one of these events, maybe more often than what my memory serves me. But I'm sure you'll tell me one way or the other here.
Yeah, we talk about an oscillation and, back and forth. It's a pretty sloppy oscillation, to be honest with you. And they occur, El Nino, La Nina, maybe every 3 to 7 years. So they're not like clockwork. They kind of come and go. And there will be periods of time where you have more of one and more of another later. And it is interesting. And you're right, Clint. This is the second La Nina in a row. But actually, if we look back, La Ninas more often than not do sort of pile up one on another. About 70% of the time, if we have one La Nina, the next winter will be a La Nina. El Nino is not the same. El Ninos don't stack up. And I think it's a lot that, they sort of, in many ways, an El Nino depletes all that hot water in the Western tropical Pacific because it surges along the equator back to the west, and it gradually dissipates and cools off. And it takes a while to build that back up. La Nina is just sort of the strength of the trades and keeping that cold water in place. So El Nino itself, relatively short-lived, typically, 9 to 12 months. La Nina, more often than not, a couple in a row.
Well, I'd like to get to, some of the weather impacts that this ends up having on us across really across the Midwest, right? We've already had some really what I would consider historic events, it seems like, that's happened here this past month. Whether it's a tornado event that went across Kentucky and Illinois and a few other parts there that impacted. I think that tornado I heard was on the ground for like 166 miles, right?
Crazy. Yep.
And then followed by the very next week, historic wind events that swept across Nebraska, northern Iowa, into Minnesota. Did they have a direct relationship with La Nina then? Is why we're seeing like these heavy storms in the wintertime?
Yeah. Great question. And one we get all the time in the weather community as far as, well, is this storm a result of global warming? Or is this, and we can't give attribution to any single event. We can't say this is because of La Nina or this is because of El Nino or global warming. What we do know is sort of how it shifts odds, right? I mean, and that's really what forecasting and all of this is about, is we can look at, if we look in the past or if we understand the physics and run a lot of computer simulations, we can understand how certain patterns shift the likelihood of severe weather or shift the position of the jet stream on average. It doesn't give you information about a single event. But with that in mind, what we do know is that, tornadoes in December are rare. But they happen, tens of tornadoes a year on average, southern tier of states, Gulf Coast into Florida. And we do know that if you look back in history, that sort of the severe weather activity shifts a little bit farther north with La Nina. So, that's consistent with what we saw. We also know that the jet stream during La Nina is a little bit farther north. And then that's consistent with what we saw coming out of Colorado with those strong winds. They had the strong downslope winds of Colorado, and that storm just worked its way out across the western plains. So each of those storms is consistent with the shift in probabilities that we know are associated with La Nina. Did La Nina, in any way assure or account for it? No, but it shifts the odds enough that it's consistent.
Gotcha. Nope, that makes sense. Is it having an impact on this nice mild weather that I'm having currently where I sit? I mean, if I look at the temperature gauge, it's almost Christmas and it's like, 50 degrees outside. So we're typically, a lot of years it's, snow packed, we got ice, we got, cold weather. And it seems like it's been a very, I'm not complaining, so I don't want to complain about this, but it seems like a very mild December so far in regards to temperature.
Yeah. Yeah, well, we certainly had in fact, last time we chatted, we were sort of expecting a rather dry and mild fall, and that really materialized. It's been very mild across the Midwest and overall quite dry. As we move into sort of the peak of the impact of La Nina, what we'd expect to see is coldness across all the northern states, except for maybe extreme New England. So from the Pacific Northwest, across Montana, all the Dakotas, Minnesota, Great Lakes, should on average be colder than normal. Flip that side, go across the southern tier of states, on average, the southern tier is warmer than normal. So that's what we should see. And the models, for the most part, are supporting that. And the observations, like you say, it's been a little bit mild farther north than we might have expected. But when we look ahead over the next 6 weeks or so, we see the potential for another Arctic outbreak pushing all the way down practically to the Gulf Coast, then working its way back north. So there will be pushes of cold air. The cold air will stay primarily across the northern tier of states. And then rainfall-wise, precipitation-wise, it really is sort of a couple places tend to be wet, which is the Northwest, and then a little bit in the upper Great Lakes. We are seeing the wetness in the Northwest, and that's been there all fall, and that looks like it's going to continue. The upper mid Great Lakes region, we're not quite seeing the wetness there. We're seeing a little bit down farther south, but overall from about the Rockies all the way to the East Coast, the odds are for it being a little bit drier than normal.
It's interesting you talk about the cold air shifting south, because that was going to be one of my questions. I remember last year, we had that really cold event. I think it was in February, where there was freezing temperatures clear down in like down in the Gulf of Mexico, right? Clear down into the deep south of Texas even, that typically don't see those kind of weather events. Again, would that be consistent with the La Nina to have those kind of, maybe not that far, but to have a little bit of push of cold air south?
That's a great question again. On average, what you do see is you actually see warmth across Texas and Oklahoma even, and farther all the way into the southeast. It tends to be warm. But we also know that there's a lot of cold air in Western North America during La Ninas. And it's been there, actually, Eastern Alaska, Northwest Canada is probably one of the coldest starts to a winter they've had in a long time. It's been very cold up there. And so that's sort of the average pattern. But then occasionally this jet stream that we expect to kind of come in across sort of mid-states, across Colorado and that's kind of the boundary between cold air to the north and warm air to the south. We know occasionally that gets a little bit of a wiggle in it. And if it does wiggle and it drives some of that cold air south, there's a lot of it available. So it's sort of a secondary effect. How about that? We pool up a lot of cold air up north. We can be pretty confident the northern states are being cold. It's a little bit less confidence or uncertainty, but occasionally some of that cold air can push well south. And like I said, when we look out a few weeks, the models are saying that there's a shot that we'll get another cold surge early next year.
Well, I always like the cool terms that the weather community like attaches to those types of events. I think it was a few years ago that the first time I heard polar vortex, right? And there was a polar vortex coming down on, like I said, right where we're at, right? Which that brought like, I don't know, -50-degree wind chills, I think is what we had. It was freezing. And but it's always interesting to hear those different terms, and now when we hear those things, it's like, oh no, I don't want that again. Not looking forward to any polar vortex around home anyway.
Yes, indeed. It's fascinating to those of us in the business as well, because they come out from, some of them you can trace back to even some research where someone decided that this is worth labeling. Others where it was some very creative editor somewhere decided this will get readers or something, and they put it there and it catches fire. And so yeah, polar vortex, they happened before. And they're going to happen some more, but it was new and exciting, and now we're going to live with polar vortex. The new one on the block is atmospheric rivers, that probably you hear about less in the Midwest, but out on the West Coast, this can tie back some really fascinating research on weather patterns in the Eastern Pacific and how storms come into the West Coast. Got labeled atmospheric river. It's kind of cool. Right? It's a cool name. And if you look at the flow of these storms, it accounts for like 70% of the rainfall in California. Wow. There's a lot of focus on atmospheric rivers now. And so here in the Northwest, all of a sudden we're getting headlines about another atmospheric river headed to Washington, or British Columbia. They had just terrible floods, destructive, fatalities, and just did tens of millions of dollars worth of damage. They had probably never had atmospheric river on the front page of their papers. They do now.
Yeah. As we shift to kind of looking at just some of the weather that we can kind of expect, I know that there's areas of the U.S. that have been incredibly dry. I think I think there's areas in California and in that area that have been pretty dry on average. And then there's other areas that, there's been still some flooding and things of that nature that have happened. I mean, are we looking at more of the same, of the similar events that happened last year? Those of us that got too much rain or not enough rain, do we kind of expect that same kind of thing, or can it shift enough year to year that we may not know that as of right now?
Yeah. Well, let's talk first about sort of how we went into this. As you said, we went into the fall and winter season with exceptional drought across much of the Southwest and West, and severe drought into the Dakotas, Western Dakotas. We recovered a bit in the fall, but there was dryness essentially from the Canadian border to the Mexican border. Less soil moisture than we'd like to typically see, and excessive moisture off into the Ohio area, Ohio River Basin, those areas. So that was the pattern that we went into this. La Niña pattern itself favors dryness across the Southwest. So the initial feedback and projections were saying, Southern California doesn't look good. And then as you get farther into the higher plains, the Climate Prediction Center was forecasting drought to expand in Texas because of the expected dryness there. And so that pattern, I think, except for California, back to California a minute, that pattern looks like it's evolving, it's there. So we had dryness, we're going to see continued dryness. So those areas, through spring or so, there's not a lot of indication that they can expect much recovery from that ongoing drought condition in the Western Plains. California, for whatever reason, this is where the mysteries of the atmosphere, they've had a couple really good storms. And even though we weren't expecting them to penetrate down into Southern California, they have. And right now, what we're seeing as we look out again, a month or two, we see that several more storms should spread up and down that California coast. So things are looking a little bit better sort of for California. And things are very, very wet up in the Northwest. So the Western drought is beginning to be eaten away a bit. Good. As you get farther east, There's some indication that even western Colorado might get some snow. They really need snow. The ski resorts are struggling on man-made snow right now. There's some indication of some relief through there. But then you get again to the western plains and North Dakota, South Dakota, into Minnesota. Dryness is probably the best bet for this winter through early spring.
If you're in one of those areas where you were struggling with moisture, is that kind of the expectation, of going into this year?
Yeah, there's no real indication of a big pivot anywhere. Sort of what you've been experiencing through this, I think, this winter. And then even next summer, La Niña fades away. 50-50 chance it will be back to ENSO neutral, neutral conditions in the tropical Pacific. But there are other patterns that the seasonal forecasters use. And right now, this coming year is looking a lot like this past summer, where we'll have, the dryness across the north, wet across the eastern, from Illinois eastward, it'll be wet, and warmth across the south, but Midwest, upper Midwest, average temperatures or so is what we're looking at right now for that area for the growing season. So sort of an early start to spring, especially south, because of the warmth with La Niña. And so it should be warming up a little bit more quickly than average. And then as you get it into Dakotas, they might have a delayed spring as La Niña fades away March into April.
Just with a longer, maybe a colder spring. Then is that kind of what you're thinking? Yep.
Yeah.
Now, what time frame, Brad? Like when you start looking we get into next year, so we know we're going to have this impact of La Niña. At what time throughout the year do you know the next year's cycle?
Again, they peak in the midwinter season, northern hemisphere winter, and then they go into the spring season. Then there's sort of what we used to talk about a barrier in forecasting, whereas they fell apart. We really didn't have a lot of clues on what was going to come out the other side. So sort of late spring into early summer, you kind of sat back and waited. More and more, we have better modeling going on, better what we call coupled models, where the atmosphere and the ocean are actually put together in the computer simulations. So we're getting better at it. But at this point, I think we can say by July, we know pretty well what the state of the tropical Pacific is going to be through all through the next winter season into the spring. So before that, a lot of uncertainty. By July, you're getting a pretty good signal whether you're going to have El Nino or La Niña or ENSO neutral. By the time you get to September, it really is in the bag. We're not making a lot of mistakes. We can, there can be, we can miss it, but by then you can be pretty confident that you're seeing what card, the atmosphere is playing.
So the other thing that you've talked about is just, the accuracy of forecast, right? And, it seems like you can get really accurate on, like, let's say a 3-day forecast. You're fairly accurate on a 10-day. And then once we start, getting further and further out, it's more and more uncertainty. Does having an event, El Nino or La Niña, make it easier to predict the weather, the upcoming weather, like the actual forecast, right? As it does in an ENSO neutral time frame?
Well, it doesn't probably make a heck of a lot of difference in the first week's forecast, because all of that's really what's determining our next, 7 days or 10 days of weather is already in the atmosphere itself. The jet stream's doing this, and the cold air's here or there, and it's already sort of determined from the atmosphere itself. If you go beyond that, if you're out to 1 month or 2 months, then because of the forcing that we're getting from the ocean, then it really does. It takes away some of the variability. These strong phases of La Niña or El Nino, they kind of take out a few atmospheric options. So it locks it into a few, it doesn't mean it can't stray the other way, but it really shifts the probabilities. So whenever we can shift probabilities to some event, we could be just much more confident in communicating that, and ultimately we're correct more often than not in those cases.
Well, that's why I was kind of curious because, it seems like when we say the ENSO neutral, I guess the word that keeps coming up in my mind is the average, right? This is just kind of normal or whatever. And but it also seems like that might be the hardest time to actually be right on whatever the trends are too.
Yeah, you're right. And that sort of the best predictors that we have for seasonal forecasting are El Nino and La Nina. That's money in the bank for seasonal forecasters. If you take that out of the mix, we're left looking for other indicators. What else is going on? What are those linear trends from year to year to year? And we can eke out a little bit here and a little bit there, but yeah, you're taking away our money if you get rid of those.
You talk about these different indicators. You've talked about simulations that are ran, computer simulations that are ran. You talk about, all these different types of forecasting tools. What if you had to just pick one and said that this is Brad's favorite tool, indicator, or simulation? What is your most favorite thing to go to in regards to weather for a tool that you use?
For a tool I use. That's a good question. I have my own. When I look at my weather and where I'm going to head for a vacation, I use a lot of NOAA material. We have a lot of access to information at Climate, of course. I use all that, and I kind of do my own thing. But when I look ahead at the future and where we're going, and gains in weather forecasting and subseasonal forecasting, they've been hard fought. It's a slow process and trying to get a little bit better, and that's second week and stuff. All that, Clint, is coming from investments in resources for NOAA, computing. Atmospheric models are huge consumers of computing resources. And, I think it's economics and weather models are the two that just gobble up whatever you can feed it. And so as we invest more, as the U.S. government invests more, as the European Center for Medium Range Weather Forecasting, as they invest more, they get better and better models. And these are computer simulations, which is really the bread and butter, the foundation for all of modern day weather forecasting. So, those models, they're incredible in what they can do. When, I look back when I was a graduate student, which was a long time ago, but we would get these computer simulations and they could flip-flop in tomorrow's forecast practically. They were bad. And today, it's amazing how stable they are in that first week. We don't miss a lot in the first week. Occasionally, we'll get a little bit of a surprise. But it's just continued, scientific research and investment in weather forecasting that will pay off for us in the future. And that's what I would advocate for is ongoing investments in NOAA. They produce all the foundational weather for what goes on in the private industry in the U.S. and around the world. They produce a lot of it, and that requires investments in computing resources.
On the computer side, I always think of systems like Climate and all these other very sophisticated things that have a lot of models into them. Where do you think artificial intelligence plays a role in weather forecasting in the future?
Great question, and one that we're really just starting to get our hands around. Early on, and in some ways, sort of early examples of machine learning and artificial intelligence were some of the sort of early stuff that was done in atmospheric sciences and some statistical applications. And I think we all thought, okay, we'll start using it, but we'll keep that computer model and we'll do stuff with the output, and we'll use machine learning to improve the quality of the output. Lately, Clint, I've been seeing some scary things, scary in the fact that, wow, how does this work? Because some researchers are able now to put that computer simulation aside and start applying these machine learning models to just sort of the observations in general of the atmosphere that we're getting better and better at observing. And they have demonstrated skill out a couple weeks without ever turning on a computer simulation of the atmosphere. So I don't know where it's going. It could be, I told you, these winds have been hard fought in weather, but it wouldn't totally surprise me if someone has something come along in these next, 5 or 10 years that really changes the field of weather prediction coming out of machine learning, deep learning processes.
That is just exciting. I mean, I take it back to like even our farm, right? And Dad and I look at it as we feel like we can continue to get better the more data that we collect, right? And there's a lot of times that you collect data that you don't necessarily know what you're going to do with it, but you know that that data collection is going to be important as we continue to move forward. And it's amazing. We were just talking the other day about the number of data points that we're collecting that we never thought we would, right? Like the down pressure of the of the planting unit or things of that nature. And now we start mixing in all the different weather points that we can collect on a field. I mean, I think it just is going to continue to get just more and more fascinating as we move into that advanced learning piece.
Yeah. It really does bring it home to what we're doing at Bayer and Climate as far as mining these data. We know we know there's so much value there. And how do we start manipulating those data? And there are going to be a lot of really great surprises coming along and seeing that value that maybe right now we're collecting the data and we're not quite sure what we're going to do with it, but there will be value there.
Well, I tell you what, the last thing that I'd like to talk to you about is I know that you're a winter sports enthusiast. So what are you predicting? Where's the best spots to go hit the slopes at? Where am I going to drag a snowmobile to? Like where's going to be the best spots for winter fun this year?
Okay. Couple qualifiers. First off, I'll only talk about skiing from the Rockies west.
Okay, fair
nothing
enough.
east of the Rockies.
My little local hill up here with one lift doesn't qualify for you.
Not worth talking about. No. Initially, it was looking like it was going to be the Northwest. The resorts up here into southern, British Columbia, Whistler. A little concerned about farther east into Utah and the Rockies, and they certainly have started in Utah, inland, and in Colorado. They've started out very badly. But as I mentioned, there are just a few indicators that right now, California, they've had a few really big events. They're skiing a lot of places. It looks like they'll get some more. So I think California, good skiing coming up for this winter. There'll be some good times here in the Northwest. We have a lot of snow already. So we don't have a problem here. We'll be skiing all winter into spring. Probably the biggest question mark is you go to Colorado or Utah. That will be one. I don't know. I'm hopeful, certainly. You want them to get what they need as far as the snow, and it'd be a shame if they're skiing on Mad Main snow all winter. But I don't know. It'll be interesting. I think that the West Coast is looking fairly good and looking better, especially looking better than it did maybe even a month ago. And then Utah, Colorado, a little bit more questionable. We'll see.
Now, do you have a temperature break that you refuse to go skiing if it's at a certain temperature? Like, can it get too cold for you?
Not when I was young. Now it's Although I mostly ski out in the West, and it doesn't get all that cold out here. I was an undergraduate in Montana. There was when I was in college, my first few years in college, they would actually give half-price ski lift tickets at Bridger Bowl for if the temperature was below -20.
Oh,
and
no way.
That's when we'd go. And I can remember some pretty cold chair rides up with the wind blowing and just kind of, why?
Yeah, that gets to just be that's too cold for me. So I don't move well when it's that cold. So
no.
Well, Brad, I tell you what, I really greatly appreciate you, coming on the show again and really stepping us through just the entire ins and outs of La Niña. I mean, it's just I find this weather event absolutely fascinating for how it can be utilized to understand a lot of these events. And I know a lot of the data points that you've brought have opened up my eyes, and I'm sure our listeners are thinking the same thing. So thank you for coming on the show again.
Well, thanks very much, Clint. It's been fun. And I'll be sitting here right with the rest of you, seeing how the rest of this winter works out and where we're right and maybe where we missed it. So
yeah, and also just one more time, congratulations on the president-elect. So that is a great honor, and congratulations again.
thank you. I'm excited and humbled by the opportunity.
All right, well, we'll see you next time, and we'll go from there. So I appreciate it. Thanks, Brad.
Thank you.
Hey, I just want to give a special thanks to Brad for coming on and really explaining that La Nina pattern that we're expecting to see this year. That was just some wonderful insight. Also, thank you, the listener, for joining us on today's episode. And if you liked the episode, be sure to hit the like button, subscribe, and ring the bell to get notified each and every time that we push out new content. Also, Around the Farm is brought to you by Climate FieldView. And with that, we'll see you next time, Around the Farm.